If you remember from the previous episode, we changed the color of this light bulb from standard white to a groovier red by replacing the old LED board with a new one that I have hand soldered using some LEDs bought from AliExpress. However, there was an issue where some of these series resistors got way too hot and heated up and smoked. So what I'm going to do is make a bunch more of these LED boards, so that way most, if not all, of the voltage will be dropped on the LEDs, and there will be no resistors that to heat up and destroy. So let's go ahead and get to building. Come on. Oh, yeah. Nice. Let's go ahead and trim down those corners. Ooh, violent. This one will be bad. Nice. So here's my plan. I'm gonna take these 3 small boards that I have cut out and stack them one on top of each other, kind of like this, and each board will have its own little bit of LEDs soldered on it, and this stack of 3 boards will end up going inside the globe. So let's go ahead and get to soldering. Alright, so I have just finished soldering this first LED board, and now I have a second LED board put up here, and let's see if it fits inside the globe. It does, so I guess that means that we will continue. Alright, so I have finished soldering the top board over there, and as you can see, I added a bunch of resistors. This right here is apparently 7 10K resistors in parallel, which gives a total resistance of about 1.4 kilo ohms. And so that means that I don't have to solder a third board, although I will probably prepare and solder the third board a little bit later. And just in case you're wondering, I have already tested this with this new resistor thing on, so let's just go ahead, go through the procedure. Unscrew the old one, put in the modified one, and turn it on. It's nice and red, and this is definitely a bit brighter than last time. So I'd say that's a success. And since there are 7 resistors in there should be, and also it's dropping less voltage, so there's less power dissipation, and there are more resistors, so the power is spread more evenly, and it'll definitely be a lot easier on the resistors right there. So I think that'll conclude it. Oh, there's an issue with this lamp. If I crack it open and get the board out, you will see that a lot of these resistors have darkened a little bit, and I am fairly certain that this entire thing right here is open circuit. And if I smell it, it smells like burning resistors. So I'm definitely going to have to remove this and somehow figure out how to squeeze 10 LEDs on this little board and then put that on top of there so that there won't be any resistors in the circuit that would be able to overheat and burn up. So let's get started. Well, I added the third board, and the light bulb is already in the socket, so let's go ahead and turn it on. Would you look at that? Red light. Now we'll see how long this red light lasts before it goes out and something needs to be fixed. But hopefully, because there are no resistors, nothing will need to be fixed. Although the issue that was plaguing this light bulb before was actually, it was oddly enough an issue with a solder connection, because I guess I just didn't put the thing in correctly. And is it just me, or does the light bulb look like it's getting dimmer? This is what the light bulb looks like without the cover. I really wish that I had a thermal camera right now, because I'm kind of wondering if these things are just getting really insanely hot, and that's why it's dimming down over time. But yeah, this dimming thing with the light is definitely going to be an issue. Yeah, unfortunately, these LEDs are definitely baking in there. I will probably have to add another board with maybe 3 more LEDs on it, which will hopefully drop the voltage, the average voltage per LED, and make it dissipate less power, because more voltage is dropped on the ones that are up there. And besides, the voltage that the buck converter produces is about 61 volts. It's not exactly 60, so yeah, I'm just gonna go ahead and see if I can lower the voltage drop by adding more LEDs. Okay, so I added 5 more LEDs, and here is the light as of now. It's still kind of nice and red, but hopefully there is less current per each LED. And in fact, let's go ahead and remove the cover and take a look at the individual LEDs. There is the light without the cover on, in the fixture, and here it is on. All the LEDs still look to be almost the same brightness. Oh, and look, you can actually see a little bit of flicker in the camera. Guess it's just the ripple of the smoothing capacitor, or the buck converter, at these fairly high currents. But, let's just go ahead and wait a minute and then turn it off and feel how hot they are. Yeah, they're still quite hot. 4 boards, now with a total of 40 LEDs. Let's see if this does the charm. 3, 2, 1. Nice and bright, but is it getting hot? Ooh, interesting. I see one of the LEDs actually is not running. Did I short it out? And the light just went out, so apparently it is not working correctly. Everything still feels quite hot in here, so yeah, I'm not sure if I should just scrap this project or what, but I'm still convinced that 1 more board might be able to do it. Wait a minute. Maybe I'm being dumb. This right here could probably be a constant current power supply, meaning that no matter what, it will output about the same current, maybe about 50 milliamps, maybe more. And it doesn't matter how many LEDs you put in series, because, well, it'll still push 20 milliamps through, or well, it'll still push a set amount of current through everything. Let's turn on the lights so that we can see a little bit better. Nice. So, basically, what would probably be a better solution, instead of running all these in series, would be to have, for example, the bottom 2 boards in series, and then the top 2 boards also in series with each other, but each group of boards is in parallel with each other. So that way the current will be split between these two boards and these two boards. I hope this will work because these things are getting quite hot. First of all, a quick test, because if my theory is true, then these two bottom boards connected right there with no resistors should be able to work just fine. And I have shorted out the connections that would be replaced by those other LEDs. So let's go ahead and put this thing on and replace the bulb. 3, 2, 1. Works. And each one of the LEDs appears to be about the same brightness as it was last time. So here's my plan. I'm going to replace these short wires with some longer wires and connect them up to these terminals of the contact, and then just have them go up over here like normal. Let's go ahead and solder all those wires and stuff off camera. Alright, so here's my creation. This stack is in parallel with this stack, so that way that the total current will be split between the both of them. Let's see if this works. And produces a dimmer light. 3, 2, 1. Still very bright. Don't know what to say about this. It's actually, I think this is brighter than I've ever seen before. Maybe it is actually constant voltage, and I have to continue adding more and more LEDs until something happens. But let's go ahead and feel the temperature of those LEDs. They're not as hot as I expected. Let's let this run for a while. It's been a while, and one of the LED strings has cut out, so yeah, it's still overheating. Yeah, I think we're gonna have to call it a day on this one. Who knew modifying an LED light bulb of all things would be so difficult?